Hi, this is Tom, and welcome to Lesson 19, the Standard Normal Distribution. So we're going to take a moment, and we're going to develop the idea, and then probably in the next video, we're actually going to see how we can utilize the idea. So here we go. I have this frequency distribution here with classes and the frequency, and we're going to do a few things with it. First, we need to find the mean. So we'll write that, find the mean. Oops. Find the mean and standard deviation. Oops. And standard deviation. All right, here we go. So the mean, x bar, comes from this. We're going to take a -2 plus, we have a -1, but remember that we have 4 of those, plus 0, but we have 6 of those, plus, we have a 1, we have 4 of those, plus, it looks like 2, and we have 1 of those. So I'm going to add all those up, and then we'll divide by our total frequency of 16. So when we do this, we have, let's see, we have a -2, -4, plus a 0, plus a 4, plus a 2. And notice that it looks like we have a -2 and a +2 here and here. We have a -4 and a +4, so those are all 0. Plus we have a 0, so if we add all that up, that's 0. And if we divide it by 16, we have a mean of 0. Okay, now the next thing we want to do is we want to find, and we're going to actually use the variance of Sn squared. This is the uncorrected sample variance. And this is just unique to this example, but let's try this. So what we do is we take the data, so we take -2, we subtract the mean, and we square that, plus. We take our next value, which is -1, we subtract the mean, we square that. But notice that we have 4 of those, plus. We take the data, subtract the mean, which is 0, we square it, but we have 6 of those, plus. Take the next data, that's 1, we subtract the mean, we'll square that, and we have 4 of those. Plus, our last data value is a 2 minus the mean of 0, we'll square it, and if you want, we could remember we only have 1 of those. And then we're going to divide that, by 16. So -2 minus 0 squared is going to be a 4, plus -1 minus 0 is -1, but we square it to get 1. We multiply it by 4 and we get 4, plus the 0 minus 0 is 0. We square it, it's 0. We multiply it by 6 and it's still 0. Look at that. Plus, our next one is 1 here. Is 1 minus 0, that's 1. We square it to get 1. We multiply it by 4. 1 times 4, that's 4. Plus, our last term here is 2 minus 0, that's 2. We square it, that's 4. Multiply it by 1, it's still 4. And we add all those up. That's going to give me 16 16ths. Well, that's just 1. Now, I have here the uncorrected sample variance, so to get the uncorrected standard deviation, I would take the square root of the 1, and the square root of 1, well, that's just 1. Interesting. So we have a data set here with a mean of 0 and standard deviation of 1. That seems just too nice. And let's see what happens with that. So what we're going to do now is I'm going to take and let's make a copy of our frequency distribution. We're going to use that again. I'm going to bring it, and we're going to come down, and we're going to make a histogram of the data. So let's put it right here. Paste. It doesn't even need to be that big. It just needs to be visible for us. Okay. So if I make a histogram, I'm going to have my class boundaries. Well, let's just do this. So here's what I have. Here's my -2, here's a -1, here's a 0, here's 1, and here's a 2. So my class boundaries are going to be the half unit. So let's just use a little half marker. So there will be one at, oops, I forgot my -2 there. You should tell me that before I go on. And then I have another one at -0.5, at half, 1.5, 2.5, and at -2.5. So let's put up our frequency count here as well. Now, when we do this, though, we're going to do this in percentages. So, and we could think of these as sixteenths. For example, we'll have 1/16, 2, 3, 4, 5, and 6/16. But let's go back for a moment. Notice that if I have 1/16, if I put that in my calculator, that's 0.0625, or you could think of that as 6.25%. So this first one is 6.25%. That's why I already have the percent sign right there, so we won't write that again. So then if I go to the next one, that's going to be 12.5% of the data. So we'll go 12.5, and then 3/16 is going to be 18.75%, and 25%, 31.25%, and finally our last one is going to be at 37.50%. So here we go. We're going to then make our histogram. So let's use a different color. I think it looks better and it's easier to see. So my first class is right there. My second one, well, that's going to go all the way up. My next class has a frequency of 4, which is the same as 25%. So that's going to come up like that and like that. And my next one is going to go all the way to 6/16, which is the same as 37.5%. And remember, you should, if you're not sure of that, well, I should write that down. For example, 1/16 is 6.25. You should take a moment, maybe in your calculator, try 4/16, and you should come up with 0.25. So if you multiply that by 100%, you'd end up with the 25%. And so if you're unsure, you should pause the video and take a minute and just double check that I've done those right. And just if you have, for peace of mind. Now, let's try our last one. Our last two continues over here. We have one. Our next one is the class contains the ones. And our final one here, our final one is this one. Now, here's where the ideas we've already played with, but we're going to try them again. I'm going to use a little bit different color here. If I color in this first, I'm going to do it this way, you'll see why. If I color in this first bar, then that represents 6.25% of my total data. So this is 6.25% of all data. Now, let's take this and let's try it with a green. Now, what if I colored this first bar, and then I kept coloring, and I colored this second bar? Well, then what I've done is I've colored 6.25% plus, or I should write my percent sign, percent plus of another 25%. So that's 31.25% of all data. And I could continue this process. And so if I did this, soon I would, if I kept coloring, I would color, if I colored all of the bars, if I colored all bars, so all bars shaded, we'll do that, all bars shaded is 100% of the data. So by coloring the bars, the percentage that represents is another way of representing the percentage of the data. Now, let's take a few more looks at this. If I look at this, I'm going to put right here at 0. We said this is our mean, and we've used this little triangle symbol here. That's our mean. It's right there at 0. Now look at this picture closely. Notice that the left-hand side is exactly like the right-hand side. If I could fold right along the mean, fold this in half right on that line, then the two sides, if my drawing was perfect, my two sides would perfectly match. Now, that's an important idea because here's what happens next. So right now, I have data that's just in whole numbers, but what if I had data that was in tenths? So in other words, within the data from 0.5 to 1.5, I would have to divide that into 10 different spaces. Well, what would happen then is I would have to break this up into these little tiny bars. And the closer the bars were to the mean, there would be more. And then as we got away, there would be fewer. And as you can see, that's only 3. There's 4. There's 5 bars. That gets me to the halfway. And let's see if I can keep doing this. And then if I come up the other way, there's 6, 7, 8, 9, and you can see that just cutting it into tenths, that's a lot of bars. Now I can't draw this, but suppose I could. Suppose I could measure this in hundreds. That means within each single little tiny rectangle, I would have 10 more rectangles. And if I continued this process, and then I was to connect to all of these, the tips of all of these rectangles, boop, 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 just like that, I would get this beautifully smooth curve that looks much better in the notes, but I would get this beautifully smooth curve that's equal on both sides. And this curve has a mean of 0, and it has a standard deviation. I'll abbreviate SD. It has a standard deviation of 1. This picture, the idea of going from whole numbers to an infinitely small number of rectangles so close together that they make this beautiful picture, that we call this the standard normal distribution. The standard normal distribution. Okay. And you can, I think what we'll do is we will take a look at how to use this in our next video. See you in a little bit. Thanks for watching.